This video will show you how to use Microsoft Excel to complete your third and final lab in Econ 261, Principles of Statistics. So we are going to be using Excel to figure out the sampling error potential, and to calculate z-scores for means that you will then use to look up values in your unit normal table outside of Excel. So this scenario is 200 new clients who just signed up for the Consumer Credit Counseling Association program that's aimed at helping students pay off their student loans. Well, graduates pay off their student loans. So if we look at the data, each row represents one person, and column A represents the client identification number, which was assigned to them based on the order with which they joined. And then column B is how much debt each person has. And if you look, we have 201 rows because we have 200 new clients, and that first row is taken up by the data labels. So in looking at your lab, the first thing that you'll be asked to do is to create a grouped frequency distribution graph. And the reason that I have you do this is to identify whether or not the sampling distribution will be normal based on the shape of the population distribution and what we know about the central limit theorem. So let me show you how to create a grouped frequency distribution graph using Microsoft Excel. And this is something that we actually talked about in Chapter 2, but I don't think we ever did the grouped frequency distribution graph. We just did regular frequency distribution graphs. So I want to show you how to do it now. So we are going to use the pivot tables function to create this grouped frequency distribution graph. So we can go to Insert, click the arrow below Pivot Table, select Pivot Chart, and the range that we want to look at are the student loan debt. And you want to include the data label here. And actually, let's make this quicker. Let's just click the top one, scroll down to the bottom, go to the last one, hold down Shift, and click it. And it selects everything. And let's go ahead and put this in a new worksheet, and then click OK. And before I forget, let's rename this worksheet. So I left-clicked the tab, left-click, rename. Let's name it Distribution. Okay, let's click back into the pivot chart. Let's go ahead and scoot this down a little bit. So drag this student loan debt to the axis fields, and then also put it in the values. Also, make sure that the values don't represent the sum. You'll see that these are just the same thing because there's only one of these, which you'll see in a second when we do count. And so this plus nothing gives you that value. If we're taking the sums, we want the counts. So you'll click on the arrow next to Sum of Student Loan and go to Value Field Settings and then select Count. And now this is like a regular frequency distribution table. The pivot table function automatically puts everything in order from the lowest student loan debt up to the highest amount right here. And there's only one of each value, which is represented in this column. And you'll see that the frequencies add up to the sample, well, actually the population size of 200. So this is technically a population that we're looking at. Now, if we look at this distribution, it's rectangular because there are no repeats. So this isn't very informative. I'm going to make this a little bit bigger. So again, it doesn't really tell us the shape of our data because every single value really only occurs once because there's such a large degree of variability here. So let's go ahead and construct a group frequency distribution, which will give us a better picture of the true nature of our data. Are things starting to cluster in the middle, or do we have more values that are higher or more values that are lower? So to do that, you go to the, let's see, oh, we want to be in the pivot table. So make sure that you are somewhere in here, and you want to go to Options. And just make sure that you've clicked at least one of these numbers for student loan debt. Go to Group Field, click on that. It'll automatically start you at the lowest value and end at the highest value. So if we look, so 28,169, all the way up to 80,091. So again, make sure that you've clicked on one of the student loan debt numbers. Under the pivot table tools options, select group field, automatically min and max, and it automatically groups it by 10,000. Excel knows what makes sense and what will look good, and I agree. So just click OK. And now we have a grouped frequency distribution. And you can see where this picture is coming from. It's coming from this data up here. And each different group has a class width of 10,000. So this first one is from $28,169.18 to $38,169.18. And then the next one this one doesn't include $31,000 or $38,169.18. It's just to it. And then this value is included here to this next value. And they each have a width of $10,000. So they're mutually exclusive and all-inclusive, just like what we talked about with group frequency distributions in Chapter 2. And the point of this was to get a nice, pretty picture of the true distribution in our data, which wasn't possible with the other method because, remember, every single value only occurred once. So you want to clean this up a little bit. I would select this, go to the Design tab under Pivot Chart Tools, select Layout 1, get rid of this thing that says total and this thing that says total. And then if you go to Layout and go to Axis Titles, title below axis, axis title again, go to primary vertical axis and vertical title. And let's label these. So this first one is frequency. And then this title is student loan debt. Now let's go ahead and copy and paste this into your actual lab assignment. So left click. Make sure when you click that you don't see these little dots and squares. Make sure you click outside of that so you highlight the whole thing. Hit Control C. Go to your lab assignment. Hit Control V. If you want to paste it special, you can click on the little arrow below Paste under the Home tab. Select Paste Special. And I usually like to do a meta file. And then it doesn't get all funky when we try to shrink it or change it in any way. So now you'll be able to answer these two questions. Does the distribution form a normal curve? And then based on central limit theorem, will we think that the sampling distribution will form a normal curve? And I'll give you a hint. It doesn't have to be a perfect normal curve, be called a normal curve. It just has to be approximate, not crazy skewed in any positive or negative way. So then number 2 asks you to take a random sample with replacement of 10 new clients. And we're going to do this in the student loan data that we were looking at before. So this tab where the data is. And one thing that I want to say is that the sampling tool in Excel automatically samples with replacement. So again, we want to find a random sample of n equals 10 clients. Now, you may get a sample that doesn't look like mine when you do this, and that's perfectly fine because, again, it's a random sample. So everybody is probably going to get a completely different sample, and that's totally okay. So let's find this sample, and then let's calculate the mean for this sample. And so I know that I'm going to be putting my sample here, so I'm going to go ahead and label this. N equals 10. And then I'm going to go to my Data tab, select Data Analysis. And actually, let me show you how to get this Data Analysis tab, just in case you just panicked when you realized you didn't have it. It's really simple. Just click on File, go down to Options, select Add-ins, then make sure Analysis Tool Pack is selected here. Click Go. Make sure that there's a check mark next to it, and then click OK. And then once you select the Data tab, you'll have this Data Analysis option. Okay, back to sampling. So you'll click Data Analysis, and you'll see that sampling is towards the bottom of all the options. So make sure it's selected, and then click OK. The input range is all these values. This is your range. If it's not automatically selected, then you can do what you did for your pivot tables and select the first one, scroll down, hold down the Shift key, and left click the last one that you're interested in. Make sure that this random is selected and that the actual sample size is here under number of samples, so 10. And then your output range, you can click here and then click here to say, I want it to start here. Click OK. And there is our random sample of 10 different people. And you'll see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 new clients in this sample. So let's go ahead and calculate the mean for this sample. And let's label this. So let's put mean here. And I'm actually going to put a line below this data to separate the last number in our sample, the last loan debt in our sample, from the mean. So you can go to the Home tab and then see this little border option here. Just click bottom border when this is highlighted. And now we can have a nice little separation. So to find the mean of the population, or to find the mean of this sample, you would do equals average and double click, and then you would highlight all that data and then hit enter. So again, the equal sign, start typing average, and this will pop up, average, double click it, highlight all the data in your sample, hit enter. And that is this sample mean. So your lab assignment will ask you, I just calculated the sample mean, it'll ask you what is the sample mean. So go ahead and just copy and paste that out of your Excel sheet. So highlight the mean, hit Control C, and then you can paste it right here. Now, it made the formatting get kind of strange, so to prevent that from happening, once you paste, you can hit this little Paste Options box, and then just select the key text only, so the little clipboard with an A inside of it. And if you really want to be kind to me while I grade your labs, you can highlight your answer, hit Control B, and bold it, so it'll be easy for me to find. Now here, below the sample mean, use Microsoft Excel to calculate the sampling error for this sample of n equals 10. What is the sampling error? Okay, so remember, to find the sampling error, you need to take the sample mean minus the population mean. So before we can find the sampling error, we're going to need to calculate the population mean and then subtract that from the sample mean we found, and then we'll get our sampling error. So I'll show you how to do that in Excel. So let's go ahead and calculate our population mean. Let's go all the way down here, and let's label this mean. Let's go ahead and put a bar below this last value just to keep it separate. So under the Home tab, select this little guy here. And then let's type in equals, start to type average, find average here, double click it, and let's go ahead and select the entire range for our population. So I'll click this last value, I'll scroll up, hold down the Shift key, and select this value. Let's scroll back down, hit enter. That is our population mean. Now, if you like the way that this is formatted with, decimals and commas and dollar signs, you can format our sample like that as well. So you can highlight all this and right click, go to Format Cells, select Currency, and it automatically does the 2 decimal places, which is what we already have going on here. Click OK, or maybe not. I guess it wasn't 2 decimal places. There we go. Now it's formatted like our population. I think that looks a little nicer. In fact, I'm going to copy this from here and put it into my document here. Oh, did the funky formatting again, so I'll just hit this box and then the little text. Okay, so we aren't ready to find out or to put in our answer yet. This isn't asking for you the population mean, it's asking for the sampling error. But I calculated the population mean because that's a necessary component to find the sampling error. So let's go back to our lab document. I'm going to go ahead and label this below here. Well, let's label it here, sampling error. This is where I'm going to be doing my calculations for the sampling error. And remember, the formula for this is the sample mean minus the population mean. So to tell Excel that you're getting ready to do some math, to do a formula, you hit an equals sign before you do anything else. So an equals sign, and we're going to take the sample mean, so I'll just highlight the sample mean, minus, and let me find my population mean, the population mean, and you'll just see that I identified the cells where those values are, and then hit enter, and that is my sampling error for my specific sample of 10 compared to the population. So when you do your calculations, you should get the same exact population mean because we're all working from the same population, but you are going to have different sample with a different sample mean and therefore a different sampling error. So let's go ahead and copy and paste this into the lab assignment. Control V and then save it as a bold. So now you'll just repeat the same process for number 3, only when you go to calculate your sample, let's go here, put n equals 5, data, data analysis, sampling, okay. Still have the same input range, still have the same population, only now the number of samples will put 5 there because remember, now we're looking for a random sample of 5 clients. So let's go ahead and change our output range as well. We want to put it here underneath where we labeled n equals 5. Click OK. 1, 2, 3, 4, 5 people that were randomly sampled. And let's go ahead and find the mean for this one as well. And then we're also going to be finding the sampling error. So let's see here. I am going to put my little bar below just to keep things organized. And then type equals AVE. There's average. Double click. Highlight those values from our sample. Hit enter. And then I'm going to go ahead and format these so that they are dollar signs, their currency. So highlight it, right click, format cells, currency, and then click OK. Now let's find the sampling error for this sample. So equals the mean for the sample minus the mean for the population. So let's get it. And then go back up, hit enter, and that's our sampling error for this sample. So I'm going to highlight this, hit Control C to copy, and then I'm going to put that here. Oh, it didn't give me my little tab option. Oh, where'd it go? That's being funky. That's fine. I'll just bold it. And change it back to Times New Roman. And I've got to scoot this guy over. So I'll just click on this, go up here, and drag it over. So if you can't get the little thing to pop up, I just showed you how to get it back into the original formatting. If formatting is an issue for you, it really bothers me if formatting gets crazy. And let's make sure that we put the sample mean in here as well, which I already found. So Control C to copy that. And Control V to paste. And let's bold it. Just like before, your answers may vary from mine. You're probably, in fact, more than likely they will. You're going to have a different sample with a different mean and a different sampling error, and that's perfectly fine. Now, keep in mind, and we talked about this in class, this is kind of a review to help you with your quiz. Here we had a smaller sample, and coincidentally, we had more of a sampling error. Remember, sampling error is all about absolute value. In both cases, our sample underestimated our population. But with the smaller sample, it underestimated it by more than with the larger sample. But that doesn't always have to be the case. We may, just by random chance, get a more representative sample with the smaller sample and a less representative sample with the larger sample, and then maybe our larger sampling, our sampling error for our larger sample could actually be larger than the sampling error for our smaller sample. So I just want to note that. It doesn't always have to work this way, but in most cases it does. Okay, let's go back to our lab assignment. So now looking at your sampling errors for 2B and 3B, which sampling error is larger in absolute magnitude? And it would be the sampling error for 3B. So Control B to bold. 3B is larger. Okay, next one. So in this data, we want to use Excel to calculate the sampling error potential. So this was the actual sampling error from an actual sample. Now we want to look at the sampling error potential for these two different sample sizes. So for this first one, for any given sample size of n equals 5, what is the sampling error potential? So now this is going to be a little bit different. So to do this, I think it would be a lot simpler if I organize these data values from highest to lowest so that we can find the top 5 and the bottom 5 samples. And now I'm doing it the hard way. Instead of just doing the top one and going to the bottom, hitting Shift and clicking it. All right, there we go. Make sure that you don't include the mean. And then you can click, if you're under the Home tab, Sort and Filter, smallest to largest. And let's just continue with the current selection. If you want to expand the selection, then it would keep these client identification numbers with the original data. And since these no longer make any sense, I'm just going to get rid of this. There we go. Just checking to make sure that our mean changing didn't have an effect here. So the same here. Look how smart Excel is. It knows that we deleted that column, so it's still taking this, our population mean, from column A. How smart. Okay, anyway. So now we have our student loan debt listed in order from the least amount all the way to the maximum amount. So now that these are in order, it'll be a lot easier for us to find our sampling error potential. So the first one is asking, what is the sampling error potential for a sample size of n equals 5? So if we want to start looking at that, we need to find the sample mean for the bottom 5 and the sample mean for the top 5. And then we'll take each one minus the population mean, and that'll give us our range for our sampling error potential. So I'm going to go over here just to keep everything organized and type in bottom 5. Let's do mean bottom 5. Mean bottom 5. I don't like the way that looks. I'm going to scoot that down here. Okay, mean bottom 5. So I can type in equals, start to type average till it pops up, double click. And my bottom 5, since these are now in order from highest to lowest, will be 1, 2, 3, 4, 5. And then click enter. And that's the mean for the bottom 5. Okay, so we've got our sample mean for the bottom 5. And now let's find the mean for the top 5. Mean top 5. So let's type in equals and then average, double click, and let's go down here and get the top 5 scores. So 1, 2, 3, 4, 5. Make sure you don't include the mean. And then we've got those highlighted. You'll see that here and here. Hit enter. And that is the mean for the top 5 scores. But that's not the sampling error potential yet, right? We have to take this minus the population mean to this minus the population mean. So we've got the mean for the bottom 5, the mean for the top 5, and now we're ready to find the sampling error potential. So the range of values that could possibly emerge for our sampling error value with a sample size of 5 when we have this population. And really quickly, I just want to point out that this represents the lowest possible sample mean that you can get from a sample of 5 from this population. This represents the largest possible sample mean that you could get with a sample size of 5 from this population. So now let's find the bottom SEP, sampling error potential. So now we're going to find the difference between this really lowest possible sample mean compared to the population mean. So equals the sample mean minus, go down here, the population mean, click on it, hit enter, and then the top sampling error potential. So go here, click equals the mean for the top 5 minus, let's go down here and select the population mean, hit enter. So this is the range of all the possible sampling error values. You could have a sampling error going anywhere from negative 22,193.92 to 23,357.66. I'm going to go ahead and format this as currency. And one of the things that I want to point out is that if for some reason this isn't a negative value, make sure that under this negative numbers, this option is selected where it actually shows the negative and doesn't give you an absolute value. So now let's go back to our lab assignment. And it says, okay, for any given sample size of n equals 5, what is the sampling error potential? So I've shown all my calculations in Microsoft Excel. But now I need to calculate or copy and paste these values. So remember, the sampling error potential is written out as the bottom sampling error potential. So let's go ahead and highlight that, hit Control-C to copy, go here, hit Control-V, and then do the text only. And then type 2 the top sampling error potential. So go here, Control-C, Control-V, text only. And let's go ahead and bold those. So I've shown you how to do it for a sample size of 5. You'll use the same process, only with a sample size of 10. So we can go ahead and copy this, just so we have our labels. So the bottom, and I'm going to go up here to edit it, it's a little easier. The bottom 10, the top 10. So for this one, you'll find the average for the bottom 10. And then for this one, you'll find the average for the top 10. So these guys here. And then you'll do the same process as before, where you'll take this mean minus the population mean for this, and this mean minus the population mean for this, and you'll report it in your lab assignment. And then for part C, on number 5, you'll just tell me which sampling error potential is larger in absolute magnitude. And I'm telling you right now, you'll find out, no matter what, because it always works out this way, that the sampling error potential for this will have a much shorter range, less of a range, than the sampling error potential here. Because no matter what, anytime you have a larger sample, the sampling error potential is smaller. And that'll always be the case.